Hello, welcome back to the channel. So let's continue our previous videos on partial fractions and do one more question of this form when we have factored out terms in the denominator. So in this question, we'll solve for this integral over here, and you can clearly see that in the denominator you have an x plus x squared term over here, right? Which can be easily factorized to x times x plus 1, right? So your integral over here can be easily transformed to integral x equals 1 to x equals 2 of dx upon x times x plus 1, right? And we can clearly see in this case that this expression resembles one of the rational function expressions that we solve using partial fractions. So that is why in this case it gives us an idea that it would be easier for us to solve this definite integral using partial fractions rather than using any other approach to solve for this integral over here, right? So let's write the integral first. So we have to calculate the integral from 1 to 2 dx upon x plus x square. So now in this case, let's again first calculate the indefinite integral and then we'll plug in the endpoints to calculate the definite integral. So the indefinite integral is dx upon x plus x square, which can be easily transformed to, as we discussed, dx upon x times x plus 1, right? And now since we know that these are one of the expressions that we solved using partial fractions, so we'll write the expression over here. So the expression is 1 over x times x plus 1, and you know how to break down these integrals, right? So we have already discussed this concept in detail in the previous videos. So if you have not watched my previous videos where we have discussed about this cheat sheet in detail, I would highly suggest you to watch those videos before going over this video to solve this integral over here. So that is why if we break down this expression using partial fractions, we can easily write this expression as this form, right? So we can easily transform this equation as simply a over x plus b over x plus 1, right? And now we can solve for the constants a and b. Let's equate the left hand side with the right hand side. So if we solve for the right hand side, we can clearly see that 1 over x times x plus 1 is equal to a times x plus 1 plus b times x upon x times x plus 1, right? And now this would be equal to simply ax plus a plus bx upon x times x plus 1. Again, separating the similar terms together, we'll take x common. So this would become x times a plus b plus a upon x times x plus 1. And now we only have to compare the left hand side with the right hand side. And now in the numerator, if we compare those coefficients of both of these numerators, we can solve for the values of a and b. And now you can clearly see in this case that you don't have an x term over here, right? So that is why the coefficient of the x term is 0 in this case. So by comparison, we know that a plus b is 0 because we don't have an x term over here. We have a constant over here which can be easily compared to a in this case, right? So we know that a plus b is 0 and a is equal to 1. So if we solve for b from this side, we can easily solve b as minus a. So b would be minus 1. And now you can break down this expression 1 upon x times x plus 1 into simply a over x plus b over x plus 1, right? And we know that a is 1, so a over x would be 1 over x, and plus b over x plus 1, so b is minus 1, so that is why it would be minus 1 over x plus 1 in this case. And now we can easily write this integral 1 upon x times x plus 1 as simply calculating the integral of 1 by x dx minus the integral of 1 upon x plus 1 dx, right? And now we know that it is much easier to solve this integral over here rather than solving this integral on the left hand side, right? So if we solve for the right hand side integral, we'll solve for the indefinite integral of this expression, right? Which can be easily calculated. We know that the integral of 1 by x is natural log of x and the integral of 1 by x plus 1 is natural log of x plus 1, right? So this would be simply ln mod x minus ln mod of x plus 1, or you can call it absolute value of x plus 1, right? We take the absolute values only because we know that the natural log cannot have negative values, right? And then, since in this case you were calculating the indefinite integral, you'll add the constant of integration as well, right? And now this will be your answer to the indefinite integral of this expression over here. But since in the original question we have to calculate the definite integral from x equals 1 to x equals 2, if we calculate the definite integral, in this case, it would simply be integral dx upon x squared plus x from x equals 1 to x equals 2. This would simply be ln x minus ln x plus 1 with the limits 1 and 2, right? So in order to calculate that, let's substitute the upper endpoint into the expression and then the lower endpoint into this expression again. So it would be ln 2 minus ln 3 minus ln 1 minus ln 2 in this case, right? And if we solve it, it would be ln 2 minus ln 3 minus ln 1 plus ln 2. So now if we solve this expression over here, it would simply be, we can combine these two ln 2's. So it would simply be 2 ln 2 minus ln 3. And then since we know that ln 1 is 0, we won't have an ln 1 term over here. So this would be your final answer to the definite integral of this expression. You can also simplify your expression over here, but if you leave your answer as it is as well, you'll get full marks for your answer. So that's it for this video. And again, the main takeaway from this video is whenever you have factored out terms in your denominator, you know that you have to use partial fractions to solve your indefinite or definite integrals in these type of questions by again using the cheat sheet over here that we already discussed in the previous videos. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.